Hello, everybody. Thank you for taking the time to attend this webinar from Cambridge Technology. The topic for today is accelerating software delivery and infrastructure automation on the AWS platform. Today, we are going to talk about two very key philosophies of DevOps. One is continuous integration and continuous delivery, popularly known as CI/CD, and the other piece is infrastructure as code, also popularly known as IaaC. Let's step into the agenda for today. We're going to start with an overview of DevOps. What is DevOps? The drivers for DevOps, benefits of DevOps. Then we introduce AWS DevOps Services. We'll be talking primarily about the AWS CI/CD services and also infrastructure as code or IaaC services. Then we introduce Cambridge Technology's DevOps Services. Then we take a deep dive into continuous integration and continuous delivery, followed by infrastructure as code. And finally, we present two of our customer DevOps case studies. So let's begin the topic for today. Organizations deliver faster and achieve greater business agility by leveraging AWS DevOps services. To give an overview of DevOps, what is DevOps? DevOps is the convergence of people, processes, and tools to enable adaptive IT and business agility. Of course, the term comes as it's pretty evident. It comes from dev, comes from development, and ops comes from operations, and that's why it's called DevOps. So the development team is responsible for planning the product. It creates the team creates the code to build the application to meet the business requirements. Then we have, although we do not talk about QA as a part of DevOps, but QA is an integral or a very essential part of the entire DevOps lifecycle. The QA or the testing team assures that the application and the infrastructure updates meets the requirements. Then we have the IT operations, which takes care of ongoing operations, updates, and business continuity. So once again, development starts with the source control management, versioning the code, the build scripts, the dependency map, the component deploy, system deploy. There needs to be an automated build and deploy to the test environment, at which point the QA team comes into picture. They start testing the applications. We have test scripts, test deploy. We have baselining, benchmarking, test reports which are generated. There is a continuous feedback which comes in as a part of the testing process. And of course, the operations team, which takes care of managing the golden images, the patch management, automatic environment deploy, the start-stop scripts, the rolling updates, the security configuration and compliance. Essentially, everything needs to be automated. Everything should be code, which we should be able to save, version, measure, and evolve with over a period of time. So in a way, DevOps should also be called DevTestOps, because testing, as we said, is a very integral part of this cycle. Now, the DevOps cycle, it starts with planning based on requirements which can come from the business. Then the development team starts collaboration to build this product based on the plan. Once it is built, it goes in for testing, then planning the release, planning the deployment. That's when operations come into picture for managing and maintaining a day-to-day operation of this application and monitoring it. And then there is a continuous feedback based on the running lifecycle of the application, which goes again to the planning phase. And that's how the new sprint plan is evolved, to incorporate the continuous feedback which has come in from the business users or from other factors to incorporate newer and newer features and enhance the application. And the whole cycle continues. The DevOps drivers. There is a need for DevOps, but what are those drivers? Primarily, it is to improve the customer experience. There are simultaneous deployments which are carried out across different platforms. There is a need to improve the quality and performance of the applications. There is always a pressure to release more quickly. There has to be a greater collaboration between developers and the operations team. Now, DevOps is all about the culture or the philosophy of collaboration between dev and ops. There is an increasing development and deployment of cloud-based applications. There is an increasing complexity in the IT infrastructure. And most importantly, there has to be a reduction of IT costs. The benefits of DevOps: with the adoption of DevOps principles, clients can deliver faster and have greater business agility. The most important benefit of DevOps, although all of them are equally important, one of the most important ones is increased agility. DevOps enables near instant change deployment. The time to market is reduced by up to 50% through a streamlined CI/CD process. There is an increased quality and resiliency, increased end user satisfaction with continuous feedback. We can release sooner, we can release more frequently, and there we can we can detect the bugs earlier, and we can get a continuous feedback. There is a steady, stable, and secure operational state with system tracking and auditable changes. Now, because of the ability of releasing early and releasing more often and automating the entire workflow, there is improvement in innovation. The development team or the core engineers can focus on innovation cycles and new functionalities rather than dealing with release and deployment issues. This highly increases the team productivity. And outages, there is up to 80% outages are change related, and early identification of issues and reduction of defects across the life cycle is possible only with the adoption of DevOps principles. Now we are going to introduce AWS DevOps Services. AWS Flexible Services, they simplify provisioning and managing the infrastructure, deploying the application code, and automating the software release process, and finally monitoring the application and infrastructure performance. Why AWS for DevOps? It's fully managed services. They're built for scale, whether it's a single instance or we would like to scale to thousands. Programmable, we have AWS CLIs, APIs, and software development kits. Automation, deployments, container management, configuration management. It's secure with the AWS identity and access management component. There's a large partner ecosystem, and most of the AWS services are, as we know, are pay as you go. Now, with respect to DevOps, there are several services which AWS provides, which can be categorized into different buckets. The first one being CI/CD, or continuous integration and continuous delivery. Here we have the services like AWS CodePipeline, which helps to define the process models. We have CodeBuild, which is used for building or compiling the source code and generating the deployable or the software packages. AWS CodeDeploy, which it enables deployment of the software packages to any instance, whether it's on AWS or even on-premise. And we have AWS CodeStar, which helps to develop, build, and deploy applications. It's an end-to-end solution for the entire workflow, which we'll talk about shortly in details. Then we have microservices. Under this bucket, we have the Amazon ECS container service. We have serverless computing with AWS Lambda. The next bucket is infrastructure as code. Here we have CloudFormation, we have OpsWorks, we have Amazon EC2 System Manager, and policy as code, which is brought in by AWS Config. Most importantly, monitoring and logging, it's a key aspect. We have Amazon CloudWatch for cloud and network monitoring. We have AWS X-Ray, which enables distributed tracing, analyzing, and debugging, especially with respect to microservices architecture. We have AWS CloudTrail for activity and API usage tracking. Then we have in the bucket version control, we have AWS CodeCommit, which is a fully managed source control service for private Git hosting. Then we have the platform as a service, or the PaaS offering, which is brought in by AWS Elastic Beanstalk, which enables to run web apps without provisioning and having to deal with provisioning or managing the infrastructure. Now, as I had started off by saying that we'll talk specifically about two buckets in today's webinar. One is the CI/CD piece, and then we would take the IaaC, or infrastructure as code piece. So let's start with the AWS CI/CD services. To start with the AWS CodePipeline service. So this is the CI/CD service from AWS for fast, reliable application and infrastructure updates. The whole workflow from developing to deploying to production and then incorporating changes and building the entire model can be visually accomplished in CodePipeline. Build, test, deploy code every time there is a change in the code. We have the ability to model different stages of the entire software release process through a GUI. The source code can be pulled directly from AWS CodeCommit or S3. It can be built with CodeBuild, and there are several deployment providers available like AWS CodeDeploy, Elastic Beanstalk, ECS for container deployment, OpsWorks, or even AWS CloudFormation. CodePipeline supports integration with several third parties like GitHub, Jenkins, Solano CI, for the build process, TeamCity, and also for several testing tools like Apica, BlazeMeter, or we could even bring in our custom plugins. There is rapid delivery and improved quality, and the pricing is $1 per active pipeline per month. So right from the time a developer commits the changes in the source repository, the next step of the workflow is the changes are built automatically, then code is deployed and tested in a test or a staging environment. It goes in for manual approval. Okay, the changes look good, go ahead, and then production deployment. The code is deployed to public servers. End users or customers, they access the application, new ideas, requests, bugs come in, which again goes into the next development cycle. So this is AWS CodePipeline. The next service in the CI/CD umbrella is AWS CodeBuild. It's a fully managed continuous integration service that compiles source code, runs, tests, produces software packages which are ready to be deployed. It scales continuously and processes multiple builds concurrently. It's secure. The build artifacts are encrypted with AWS Key Management System. There are pre-configured build environments for Java, Python, Node, Ruby, Go, Android, .NET Core, and Docker. There is the ability to customize the build environment by packaging runtime and tools into a Docker image. The whole concept is made possible with a specification file called buildspec.yaml. Here we have the ability to specify build commands which need to be run as a part of the build process. CodeBuild also integrates with third-party tools like Jenkins, BlazeMeter, Ghost Inspector, any kind of CI or testing tools. The monitoring is provided in the CodeBuild console or CloudWatch. And this is the pay-as-you-go pricing. It's charged only for the number of minutes the build runs. For example, if we take a small build instance which comes with 3 gigs RAM and 2 vCPUs, it's charged at $0.005 per build minute. So essentially, what does CodeBuild need? If we look at the diagram on the right, CodeBuild needs a build project. A build project is going to tell CodeBuild where the source code is, how to pull the source code, and what is the build environment that is needed to build this project. So it uses this information to build this build environment. The build environment is nothing but the OS, the runtime, the libraries which is needed to build, and the location of the source code. So it starts from there. It gets the source code, it launches the build environment, it starts running the commands which we have spoken about in the build spec.yaml file. It executes the commands one by one to build the artifacts. Now, once the build artifacts are generated, what do we do with the build artifacts? The code build is going to store them in an Amazon S3 bucket. It also has the ability to send build notifications with Amazon SNS. While the build process is going on, the number 5 in this diagram, the build output can be captured in the CodeBuild console as well as Amazon CloudWatch logs. And we can have, one can track how the build process is going on. And that's how CodeBuild executes the build process and completes. Moving on to the next AWS CI/CD service, which is AWS CodeDeploy. Now, this is a fully managed deployment service that automates software delivery to Amazon EC2 or Lambda and even instances on premises. So what happens here? We start by creating the deployable content along with the app spec file, just like we had a build spec YAML file for code build. For code deploy, we have an app spec file which is specific to code deploy. So this tells code deploy what are the deployment commands it needs to run in the target machine. And there are several lifecycle events or hooks. For example, before deploy, during installation, after installation, validation of the services. So at each of these lifecycle events, we could write our own shell scripts to trigger certain things at each and every step of the lifecycle of the entire deployment process. So the first step, number 1, is to create this deployable content along with the app spec file. They're bundled or zipped together from the development machine, or if we are using CodePipeline, the output of code build would actually be the deployed, the artifact which is to be deployed. So this is zipped and it can be stored in an Amazon S3 bucket or a GitHub repository. Now, step 2, AWS CodeDeploy needs to know the deployment management logic or the deployment metadata. Once it has this, there is a deployment group, which is nothing but a group of, it could be auto scaling group or it could be individually tagged EC2 instances. All instances need to have the code deploy agent, which is installed. This code deploy agent is what pulls AWS code deploy to check what to pull and when to deploy. Now, once it has that information, it actually pulls the deployment artifact, which is also called a application revision or just a revision. It pulls the deployment artifacts. It executes the commands which is available in the app spec YAML file on the target deployment group or the individual instances which belong to the deployment group. So there is a reliable and repeatable deployment across different groups of instances, integrates with auto scaling and performs deployment on a new instance which is launched. There is the feature to minimize the downtime and maximize application availability during software deployment. It supports rolling as well as blue-green updates. There is a centralized control of deployments through the AWS Management Console or the CLIs to track the status of the deployment. Excuse me. There is the ability to stop and roll back to a previous version. And then as we spoke about this app spec YAML file, this enables deployment of any application and run specific actions or tests at each lifecycle event. Now, the pricing for AWS CodeDeploy, it's free for Amazon EC2 or Lambda, and for on-premises instances, it's just 2 cents per on-premise instance. Moving on to the next AWS CI/CD service, AWS CodeStar. Now, this is a service which allows to quickly develop, build, and deploy applications on AWS. It provides a unified user interface to manage software development activities in one place. It allows for team collaboration to manage access, add owners, contributors, and viewers. These are three different access levels which it provides in our projects. It provides a project management dashboard with integrated issue tracking capability. It's powered by Atlassian Jira. So once we integrate it with Jira in the same dashboard, which we're seeing on the right, below the team wiki, it's not available in this snapshot, but below the team wiki, one would actually see the list of Jira bugs out there. There are project templates it provides to enable us to get quickly started with whether we're building a web application or a web service or anything. Or it has templates for EC2, Lambda, Elastic Beanstalk. It supports several languages, the very popular ones like Java, Node.js, PHP, Ruby, Python, C#. So it's very easy to just pick one of these project templates and get started. It's integrated with AWS CodeCommit or GitHub as the source control repository. It integrates very well with AWS Cloud9, which is the online browser-based IDE from AWS, or Visual Studio or Eclipse, if one is more comfortable with these IDEs. Once we create a project in AWS CodeStar, what it does behind the scenes is it automatically creates the end-to-end delivery pipeline for right from the source control repository to the code build to code deploy, and the entire pipeline for building and deploying the software artifacts. So on the right side, if you see in the dashboard, it would also show the application activity, the continuous deployment, the actual pipeline right from the source when it was last released and changed, the source, build, an application. It shows the different the entire commit history for in the specific source code management repository. And the best part, pricing, there is no additional charge. We only pay for the AWS resources, which is actually provisioned by CodeStar. So to use CodeStar, there is no additional charge as such. Now, moving on from CI/CD to infrastructure as code, this is the next piece we will be talking about. Here, we talked about AWS. We're going to focus on AWS CloudFormation. This is the main building block for modeling AWS infrastructure as code. One can use a common language like YAML and JSON to model and provision all infrastructure resources, and this can be done across regions and even AWS accounts. This infrastructure, which has been codified, helps to serve as the single source of truth for the entire cloud environment. One can standardize the infrastructure components to enable configuration compliance. We have a safe, repeatable, automated manner to build and rebuild the infrastructure and applications. We are codifying the infrastructure as code, so this can be checked into a version control system, versioned. It can be shared, reviewed with the team members. There are safety controls and rollback triggers. One can preview the changes to an environment before actually making the changes. There is automatic dependency management between different resources, which the entire template is going to provision. And there is no additional charge for CloudFormation. What you actually pay is the resources which the template is provisioning behind the scenes. So one starts with creating a template. First, we don't have any templates. So in the diagram which we see on the right, we first start by creating a template. We save it locally or in a S3 bucket. We use AWS CloudFormation to generate a change set based on the template and the input parameter values. First time there is no stack. So what AWS CloudFormation would do is it would execute and create the create the stack. From next time onwards, once we edit the template, it would generate a change set, which would be applied once the CloudFormation. In step 4, we have the ability to view the change set, which describes the actions CloudFormation would perform if we were to execute it. And the final step is actually executing the change set to update the stack. So AWS CloudFormation performs all the changes described in the change set. Now we introduce Cambridge Technology's DevOps services. Now first, Cambridge Technology, we are 300, we are a CMMI level 5 and ISO 9001, 2000, 2700, 27001 certified organization. We are about 300 plus highly skilled and certified engineers distributed across 4 places globally. We have partnerships with we have partnerships with Oracle, with Microsoft, of course, with AWS, Tableau, with Atlassian. We have a whole gamut of service offerings, right from application development and support to big data to cloud services, managed services, to IoT, AI and machine learning, to DevOps services, and even identity and access management consulting. Now, we are a certified Amazon Premier Consulting Partner. We have competencies in big data, in Oracle, in managed services partner, and of course, we have the DevOps competency as well. So the way we categorize our DevOps service offerings is we have put it in 3 buckets. One is the advisory services, then we have implementation services, and finally the support services. Now, starting with advisory services, these are collaborative workshops to assess the business objectives, to come up with the pain points and organization culture. This is essentially targeted at evaluating the current state of DevOps in a particular organization, how matured or at what state of DevOps the organization is currently in. The processes and tools assessment, formulate business value cases for DevOps journey, and be able to plot or give a DevOps adoption roadmap and framework, client-specific blueprint for DevOps processes, practices, and tools. Then the core of our offering is the implementation services, where we manage DevOps adoption. We establish DevOps processes and tools, whether it's on the cloud or on premises. We implement DevOps best practices, platform and tools agnostic automation and CI/CD services. We have expertise across several cloud platforms. We are tool agnostic, technology agnostic. We have expertise with Ansible, Puppet, Chef, several of AWS services, which we are going to talk about, Bamboo, GitHub, Bitbucket, containerization, microservices, serverless architecture, infrastructure as code, configuration management, continuous integration, code inspection, continuous testing, continuous delivery, orchestration, monitoring. We help the customer establish a DevOps center of excellence, repeatable adoption strategies across teams and at the organization level, and we essentially guide in the DevOps journey with organization change management. And the last bucket is the support services, which is for ongoing maintenance and support for automation, CI/CD projects, infrastructure provisioning, environment management, continuous integration, code inspection, CI/CD orchestration, test automation, where we help in creating test data management creation, test environment provisioning, A/B testing, test reports, maintenance of DevOps tools, release planning, monitoring and automation, training, and operations support. Cambridge Technology's DevOps Toolchain. This is not the entire set of tools which we use, but just a good snippet of the different tools which we have expertise with, starting with source code management with the AWS CodeCommit or GitHub or Bitbucket, using build tools like build like Bundler, Maven, AWS CodeBuild, several tools for code quality analysis like Sonar, Find Bugs, Checkstyle. Then testing frameworks, JUnit, JCoco, Cucumber, Selenium, Sauce Labs. Packaging and repository with Artifactory, Nexus, or an Amazon S3. Configuration management systems and frameworks like Ansible, AWS OpsWorks, AWS CloudFormation, and eventually the deployment environment, whether it's on the public clouds like AWS, Google Cloud, or Azure, or even on VMware. And in the center, if you see the main piece which we are talking about today, CI/CD, where we have already spoken about a few of these AWS tools and services like AWS CodePipeline, AWS CodeDeploy, CodeBuild. We have expertise with Jenkins, Bitbucket Pipeline, and a few other tools too. Now we are going to dive a bit deeper into the first aspect, or CI/CD. Excuse me. Now, this is an overview of continuous integration and continuous delivery. Right from the top, where it starts with the source code, which has to be versioned. It has to be checked into a source code management system. From here, any check-in should automatically trigger a build event. These automated builds have to undergo a code quality check with static code analysis. Automated unit tests have to be run. We need to be able to generate code coverage reports. There has to be a way to publish these reports to configured users, following which, if everything is good, the environment, the test bed or the test environment should be automatically provisioned, and on this environment, the application needs to be automatically deployed. So this is all about continuous integration and continuous delivery. So CI, this is the practice of merging developers' code into a shared repositories, typically several times in a single day. The best practice is to use distributed version control system like Git. There has to be a way to trigger automated builds, run code quality checks, run the unit tests, and report issues. We should be able to have integrated, clean, and tested code, and the ability to detect errors early on. Now, continuous delivery is the ability to get changes of all types into production safely and quickly in a sustainable way. The code should always be in a deployable state. Every change is delivered to a prod-like or a staging environment and tested with complete automation. There should be fast, automated feedback on production readiness anytime a change is made. And there should be a way to do a push button deployment to production when business is ready. Now, this is the difference between continuous delivery and continuous deployment. Continuous delivery is to have the code ready to be deployed, whereas continuous deployment is the actual process of deploying it in the target environment. A typical CI/CD roadmap. On the left, it starts with the source code management and the code, where a SCM repository is set up in GitHub or Bitbucket or AWS CodeCommit. Create a repository for each product and microservices. There should be a way to automatically generate the build, whether we use Jenkins or CodeBuild. There has to be a way to verify the build, run test cases, code quality checks, and automated deployment in a test environment. And on the right, where we see the continuous delivery track, there should be a way to automate the infrastructure, where there should be provisioning of the infrastructure resources and platform in an automated way. The application should be automated with application deployments, auto scaling, monitoring. There has to be release automation with the use of CloudFormation templates or Ansible Puppet. Continuous operations with global deployments and application management and continuous feedback. Now, this is a typical architecture of our CI/CD workflow, which uses AWS CodePipeline with AWS CodeCommit, CodeBuild, and CodeDeploy. So entirely using AWS services. So what happens is the developers commit code. This is configured as a source in the AWS CodePipeline model. Now, as soon as any change happens in the source, which is in the Git repository on AWS CodeCommit, it triggers the build process, which is the next step of the workflow. Now, this build is been taken care of by AWS CodeBuild. The build logs can immediately be seen on the AWS CodeBuild console as well as Amazon CloudWatch. Once the build generates the artifacts, the build process can also run the tests with AWS CodeBuild or integrated with tools like Apica Blazemeter. Once that phase is over, the build artifacts get deployed with AWS CodeDeploy into a deployment group, which could be an auto-scaling group of EC2 instances, as shown in this diagram. And alerts and notifications can be sent at the end of deployment process to notify whether it's a success or failure of deployment. So this is a typical way of modeling the CI/CD workflow using all AWS services. Now, of course, people are free to mix and match. They can, one could already be using non-AWS services and would want to bring in certain AWS services also into the mix and be able to use both of them in a harmonious way. Now, this architectural diagram shows how the developers commit code into a source code repository. In this case, it's Bitbucket. Now, there is something called an AWS S3 Bitbucket pipeline, which triggers immediately as soon as any change is made in the Bitbucket repository. It ships the source artifact into a configured S3 bucket location. That's the job of this Bitbucket S3 pipeline. Now, this is defined as the source in the AWS CodePipeline workflow model. So as soon as this artifact are deployed or copied over to this S3 bucket location, the CodePipeline process gets triggered. It invokes the next step in the process, which could be with AWS CodeBuild, or it could also call Jenkins to delegate the build job to Jenkins. One could use the Jenkins plugin for AWS CodePipeline to achieve this. So the build process could involve several steps. In this example, we're just showing it could be a set of node modules which need to be installed, several tests which need to be executed. We may need to minify or uglify the JavaScript and the CSS files. It could be a Java a project where we need to trigger a Maven build. And once we have the build artifact, the next step, the code pipeline is going to trigger the next stage in the workflow, which is code deploy, which could again deploy to a deployment EC2 deployment group or auto scaling group of EC2 instances, as shown in this diagram. So this is what I was talking about actually in the previous diagram. So the developer commits the code in a specific branch in the repository in CodeCommit or GitHub or Bitbucket. The source in CodePipeline is configured as GitHub or S3 bucket. For Bitbucket repositories, the Amazon S3 Bitbucket pipeline uploads the artifact to S3 bucket. Then CodePipeline triggers the build. It could be with CodeBuild or Jenkins. Once the build process is successful, it goes to the next step of the next stage rather of the pipeline, which is code deploy, and it deploys it to a fleet of EC2 instances, or as they call it, a deployment group. Then code deploy could send notifications on the success failure of the deployment. Changes could be approved. There could be manual check also in this entire stage. After the deployment to a test environment, there could be an action to do a manual approval. Once somebody has validated the test environment, everything looks good, please proceed. Then it could CodePipeline could wait for this manual approval to go through, and then carry out the next action in this particular stage and do the deployment to the next environment or even production environment. Now, infrastructure as code. We already spoke about AWS CloudFormation, but how do we automate infrastructure provisioning, the entire infrastructure provisioning process? So this is where AWS CloudFormation and AWS CodePipeline meet. So with this way, one can build a continuous delivery pipeline for CloudFormation stacks. So every time a CloudFormation template is changed, CodePipeline initiates a workflow to build a test stack. One can test it, await manual approval, and push it to production. The templates and different parameter values, valued files for test and production are placed in S3 as a zip file. Only thing is this S3 bucket needs to be versioning enabled. The CloudFormation is available as a deployment provider. It allows several actions. A few of these actions are creating a stack, updating a stack, deleting a stack, creating a change set, or executing a change set. So as we see in the diagram on the right, once we have this template source with the different parameter values as a zipped file in S3, the CodePipeline gets triggered based on this source. It invokes the next stage, which can be called a test stage. The first time there is nothing, so it creates the stack, AWS CloudFormation. It waits for approval of the test stack. This is a manual approval process. Once somebody goes in who has the authority to approve it, it invokes the next action, which is to delete the test stack. And then it invokes the next stage, which could be to deploy the infrastructure in production. So at this point, it creates a change set, which again runs the AWS CloudFormation task. Approve the change set. One can see what would happen if this change set is actually applied, and manually approve it. And then the final step after approval, which is to execute the change set. So this is how the entire infrastructure can be automated using CloudFormation and CodePipeline. Now we'll talk about a couple of case studies. The first one is for a client, Eneralize. Eneralize provides solutions to reduce HVAC, heating, ventilation, and AC energy and maintenance costs for small retail and restaurant chains without a heavy investment of money or time. Excuse me. The company is transforming energy management from a hardware-heavy industrial controls approach to a software-centric and data services solution. The solution reduces energy cost by 20-30%, reduces repair cost with an early warning system, which warns for anything that heating ventilation systems which need repair, provides a premium customer experience by improving the site comfort and saves time with remote management and data insight services. So the challenges when we were building this application is this web-based energy management portal. It's on the AWS cloud. It provides centralized control and access to a wide range of energy cost, usage, and operational information, alarms, diagnostic, and analytics. But this product needed multiple builds, which have to be deployed on a daily basis. There has to be an early access with incremental value, which needs to be delivered to the customer in aggressive sprint cycles. These factors drive the need for a streamlined and automated CI/CD workflow. So the key outcomes of this engagement were instant and automated deployment across environments, a continuous feedback and increased end user satisfaction, email notification on success or failure, and the ability to detect issues early on. The product was very dynamic and needed early access in getting. So it basically follows the release early, release often paradigm to be able to get early feedback from the customer. So Cambridge Technology developed an automated, standardized, consistent, and streamlined CI/CD workflow process to deploy and promote code across multiple environments, dev, QA, staging, and production. This helped the customer realize in achieving continuous integration, continuous delivery, deploy changes to production in a really fast, reliable, and consistent manner. The highlights being a streamlined CI/CD workflow process to deploy and promote changes across multiple environments. Now, coming to the solution, this is the CI/CD workflow which was used in this particular engagement. Developers, they commit code in the source code repository, which is managed by which is there in the Bitbucket cloud. We have this plugin which we spoke about earlier, the Amazon S3 Bitbucket pipeline, which detects any change in the source code repository on Bitbucket and ships the repository or the source code to a pre-designated S3 bucket location. Now, this is when the AWS CodePipeline kicks in. It detects the change in this source or the S3 bucket location. It triggers the next stage, which is the build stage. In this engagement, Jenkins is used for building the source code and generating the build artifact. So Jenkins plugin for AWS CodePipeline is used. The build logs are seen in the Jenkins job logs console. Once the build artifacts have once Jenkins has finished, the build artifacts are again published in a S3 location from where they are deployed using the next stage in the AWS CodePipeline, which is AWS CodeDeploy. This deploys the build artifact into a EC2 deployment group, which is a auto-scaling group of EC2 instances. So the benefits which the customer or NRLies derived from by having a streamlined CI/CD workflow on AWS is increased agility and increased quality. So by introducing these CI/CD DevOps practices and methods, there it has been made possible to make instant and automated deployments across multiple environments. Early access for continuous feedback, leading to increased end user satisfaction. Excuse me. We have been able to make multiple deployments per day seamlessly in an automated way with email notifications on success or failure. There is reduced outages because issues are caught early on. There is a reduction of defects across the life cycle, and this is only made possible by having a streamlined and automated CI/CD workflow and having multiple deployments every day. There is an automated, standardized, consistent, streamlined CI/CD workflow process to deploy and promote code across dev, QA, staging, and production environments. So with this NRLize, we have enabled the customer to have multiple deployments across multiple environments through DevOps methodologies and best practices. Sorry about the interruption. The next case study which we are going to talk about is a customer called Authis. The purpose of Authis is to expose and measure the in-demand skills to thrive in today's economy. The mission is to broaden opportunity, close skill gaps, and reduce organizational risks. Authis, they have competitive information-based. They use technology which is driven by machine learning for measuring the competency, which puts people in real world scenarios and then learns from what they do. To understand if a candidate or an employee can do the work required, we need to see how they tackle complex open-ended problems like the ones they'll encounter on the job. And using sophisticated machine learning and data analytics, Authors delivers this capability. The challenges: this solution needed to follow the aggressive release early, release often, or RERO software release paradigm. There is a strong need for a streamlined, consistent, and automated CI/CD workflow. So the key outcomes from this engagement were release early, release often, improved user satisfaction through continuous feedback, reduced outages through early detection of issues, and agile business processes with AWS CodePipeline. The solution from Authors to achieve this release early, release often paradigm, Cambridge Technology developed a seamless, standardized, and streamlined CI/CD workflow to promote code and deploy the software across staging and production environments. And this helped Authors to deliver faster and achieve greater business agility. Now, this is the architecture diagram of the CI/CD workflow. Here, we've used GitHub as the source code repository. Developers commit the code in this source code repository. CodePipeline kicks off, detects the change in the source. It passes on to the next stage, which is the build stage. The build is delegated to Jenkins. Once the build process finishes, the build artifacts are deployed using the Elastic Beanstalk deployment provider to a beta Beanstalk environment, where at the same time, the deployment even triggers email notifications for success and failure. Now, in this beta Beanstalk environment, the tests are run, manual and automated tests. It waits for manual approval task or action. Once that is once the beta testing has been completed and somebody comes and manually approves that action, it invokes the next action in the deployment stage, which is deploying to the production Beanstalk environment. So with this, Authors delivered greater business agility through enhanced innovation, quality, and resilience with reduced outages. All of these features have been possible through the adoption of DevOps principles, primarily having a streamlined CI/CD workflow in place. That's all I have for today's webinar. Thank you all for attending this session. I welcome questions at this point. Thank you very much.